This video is on examples of solving right triangles using trigonometry. We're going to solve for the missing piece, and we're going to round answers to the nearest tenth when necessary. So we could be asked to solve for an angle or a side. Now, before we even begin to try and solve right triangles, we have to make sure, since we're going to be dealing with degrees, that our calculator must be in degree mode. Calculator must be in degree mode to solve. If it's not in degree mode, it will not give us correct answers. So it must be in degree mode to solve. I'm going to highlight this as well. Calculator must be in degree mode to solve. I'm going to go over this because this is really important. Must be in degree mode to solve. Now, how do we make sure our calculator is in degree mode? So if I turn on my calculator, I can actually clear it by doing second plus 7, go over to all, 1, 2. I'll just let it reset. There are two types of modes your calculator can be in. It's in degree or radian mode. So if we click the button mode, you come down here to see it says radian and degree. Right now it's on radian because that's what your calculator defaults to. You have to go over to degree and press enter on it. So now we are in degree mode. So if I now press second mode to quit that program, I should be in degree mode. So if I press mode again, I am in fact in degree mode. So if I go back and clear the calculator, because you'll have to do that, second plus 7, go over to all, 1, 2. You will have to clear your calculator regularly. So you always want to make sure that you put your calculator back into degree mode. So if I go back to mode, it's actually gone back to radian mode. So I have to make sure every time I've cleared the calculator, we press enter on degree so that now it is in fact in degree mode. Now we can actually do our problems. So whenever we're solving for the missing part of a right triangle, we can use SOHCAHTOA, trigonometry. SOHCAHTOA. The reason we use this is to help us determine which ratio we have to use, which trigonometry we have to use, depending on the ratio of what we have. So when we start doing this, we always want to find our hypotenuse because that one can be tricky. Because hypotenuse can sometimes, people will say it's the adjacent, but it cannot be. So you should always find your hypotenuse first. So I'm going to highlight the hypotenuse in yellow. What we want to do is label the triangle with everything we have. On this triangle, we have a degree here. This is considered our theta. The degree is considered our theta. So we put the theta symbol here. Now, with regards to theta, wherever your degree is located, even if the x is here, it's still whatever says degree. With regards to theta, where is everything else located? There's nothing labeled on this side, so we don't even worry about it. The x is over here. So with regards to theta, this is your opposite of theta. I'm going to label this as O. With the 22 is actually on the yellow part, so we don't even care with regards to theta. That is your hypotenuse. So we can put the H. We have everything that we needed labeled. Everything that's already there is labeled. So the question is, which ratio do we use? we have O and H. So if we come up here to our SOHCAHTOA, when do we have O and H at the exact same time? We have O and H together here, not here and not here. So that means we have to use this one. So each of these letters represent something. So we're going to write out the basic trig equation, trig function for this, trig ratio. The S stands for sine, so it's going to be sine of theta is equal to. Then it's O over H, so opposite over hypotenuse. We do this first. Now that we have our actual trig ratio set up, we can start plugging things in. So I'll do sine, that trig has to stay the same, so it's sine of. Our theta we labeled as 13 is equal to. Our opposite is our O, that's actually x. That's what we labeled as our opposite. X over hypotenuse is H. That's where the 22 was. Now we want to solve for x. On here, we have the denominator, and if we remember back from the last video, if we're solving for trig, if we're solving for a side, because we have theta, we have the denominator, we're going to do our number times the trig. Number times the trig. So our number is 22. We're going to times it by that trig of theta, which is that sine of 13. And that's going to equal the x, because that's how we're going to get x by itself. So now if we go into our calculator, we're going to do 22 times the sine of 13. We're going to close our parentheses. Going to press enter, and we get to the nearest tenth. It's 4 9/10. So x is approximately 4 9/10. Because we only had one side length, we could not use the Pythagorean theorem to find that second side length, or that third side length. So we're given the denominator, we multiply the denominator to the trig. On the second example, again, we're going to label everything we can. The first thing you label is you highlight your hypotenuse. Always highlight your hypotenuse, or mark it in some way. Now I'm going to label the theta. So 38 degrees is our theta. Now we're going to label the sides with regards to where it's located. So the 7 is directly attached to that 38, and it's not highlighted, so that means that has to be your adjacent. This is your A. Now the X is on the highlight part, so that has to automatically be your H. So now what letters do we have together? We have an A and an H together. So this does not have A and H. This one does. This one does not. So we have to use the CAH. The C stands for cosine. So cosine of theta is equal to A over H. So adjacent over hypotenuse. Now we just fill in what we have. So we keep our cosine. Our theta was the 38 degrees. Equals. Adjacent, we label that as the A, so that's the 7. Over, the hypotenuse was the highlight, that was our X. Now this time, we're given the numerator, so if we look back here, if we're given the numerator, we take that number and we divide it by the trig. So our number was that 7, so we take our numerator and we divide it by that trig of theta, so that cosine of 38, and that will give us x. So we have our 7 divided by that cosine of 38. Close your parentheses, enter. When we get to the nearest tenth, that 8 makes that 8 go up to a 9, so that's 8 9/10. So x is approximately 8 9/10. On this next one, again, we're going to label everything. So I'm going to highlight the hypotenuse first. Highlight the hypotenuse first. Then I'm going to label theta. The degree, x degrees, is actually our theta. And now we're going to label the sides. The 3 is across the triangle from the theta, so this is called your opposite. And your 4 is directly attached to that theta, but not highlighted. So that directly attached but not highlighted is your A, adjacent. So we have A and O together. So coming up to SOHCAHTOA, this does not have A and O, does not have A and O, does have A and O. So we start in order. So T stands for tangent. So tangent of theta is equal to, the next one is O, so opposite, over the adjacent. Now we just plug in what we have. So we have tan of, our theta is our x. We plug in the x where that theta is, equals. The opposite is the O, that's where we labeled that 3, over. The adjacent was the A, that was the 4. Now this time, we're actually looking for theta, because we don't have theta. If we look for theta, if we're finding that angle, we want theta, we have to do the trig inverse. So we have to do second sine, second cosine, second tangent. So this time, we have to do the inverse of it. That means in our calculator, we'll do our tan inverse of. And we actually keep that same fraction, so it'll be 3 over 4, and that will give us our theta. So again, that's our second tangent. So if we take our calculator, we're going to press second tangent, and we'll type in the number 3 divided by 4, because it's the same fraction. Press enter, and we get 36 9/10 degrees, since we are finding theta. So this time, x is approximately 36 9/10 degrees. We do want to put that degree on there because it is an angle measurement. Number 4, again, I'm going to highlight my hypotenuse. Always highlight your hypotenuse or mark it in some way. You don't necessarily have to always label it, because this one did not get labeled because it didn't have anything on it, but you should always know which one is your hypotenuse. Now to label the triangle, label your theta. The x degrees is your theta. And now we've got to label the numbers. So the 2 is through the triangle, so it's the opposite. It's the O. The 4 is on the highlight automatically, so this is automatically H. So O and H together, that's your S, your sine. So we have sine of theta is equal to opposite over hypotenuse. And now we just plug things in. So we have sine of our theta is our x, is equal to our O opposite is the 2, over the hypotenuse was the 4. So since we're finding x is our theta, we have to do that sine inverse of that fraction. So it's just 2 over 4, and that will give us our x. So again, that's the second sine. So if we do second sine of 2 divided by 4, close parentheses, that'll give us an exact 30. So that's 30 degrees. So x is actually equal to 30 degrees. Number 5, highlight your hypotenuse first, so across from the right angle, opposite the right angle. Label them. Theta goes where your x degree is. Your 6 is directly attached to that theta but not highlighted. That's your A. Your 18 is on the highlight. That's automatically your H. So A and H. A and H together, that's your C part, C. So that C stands for cosine of theta is equal to your adjacent over hypotenuse. So we have cosine of our theta is x is equal to our adjacent is 6 over your hypotenuse was 18. So since x is inside your theta, that's when you do the inverse. So cosine inverse of the original fraction, so it's 6 over 18, and that'll give you your x. So second cosine of 6 divided by 18, and you do not have to simplify it ahead of time, just type it in as you see it. And that's 70 and 5/10 degrees. So x is approximately 70.5 degrees. Six, first thing, highlight your hypotenuse, so across from the right angle. And now label the parts. So theta is where your 22 degrees is. Then you have a 3, which is through the triangle, so that's your opposite. Your x is directly attached to it but not highlighted. That's your A. So O and A together is your tangent. So we have tangent of theta is equal to your opposite over adjacent. Again, the order of the acronym tells you which goes first. So tangent, opposite, adjacent. So we have tangent of our theta is 22 degrees is equal to our opposite is 3 over our adjacent is x. Since we're given the numerator, we have to divide. Given the numerator, you have to take your number and divide it by your trig. So we have 3 divided by your trig of tan of 22, and this will equal to x. So 3 divided by tangent of 22, close parentheses, we get 7 and 4/10. So x is approximately 7 and 4/10. It's not a degree because it was a side length. Number 7, I'm going to highlight the hypotenuse and then label the triangle. My theta goes at that 41 degrees. The x is directly attached to it, but not highlighted, so this is your A. Your 11 is on the highlight, so it's automatically H. A and H together is your CAH. C cosine of theta is equal to adjacent over hypotenuse. So we have cosine of our theta was 41 degrees is equal to our adjacent is that x over hypotenuse is the 11. You're given the denominator. Since you're given the denominator, you have to multiply. So your denominator 11 times cosine of 41 is equal to your x. So we have 11 times cosine of 41 degrees, close parentheses, is equal to roughly 8 and 3/10. X is approximately 8 and 3/10. Number 8, we're going to highlight the hypotenuse, so across from the right angle. Now we're going to label the triangle. Theta is at 39 degrees. The 10 is across the triangle, so that's our opposite. The x is directly attached to it, but it's not highlighted. That's your A, your adjacent. So O and A, that's tangent. So tangent of theta is equal to opposite over adjacent. So we have tangent of our theta is 39 degrees. It's equal to our opposite is 10, and our adjacent was the x. So this time we're given the numerator. If you're given the numerator, you have to divide. So you have your numerator 10 divided by your trig. Tangent of 39 is equal to x. So in our calculator, we do 10 divided by tangent of 39, close your parentheses, and it's roughly 12 and 3/10. So x is approximately 12 and 3/10. So again, if you're given the numerator, you take your numerator and divide it by the trig. If you're given your denominator, you take your denominator and multiply it by the trig. And if your x is in the parentheses, you have to do the inverse of it. So you have to do second the trig and then put your original fraction in there. So I'm gonna have 4 more examples handwritten, but they will be extra examples.